Hello, everybody. My name is Hello. Welcome back to the series we're doing in operating systems. In today's episode, we're going to be talking about least recently used page replacement algorithm. We're talking about page replacement algorithms. This is the second video of that sub-part series that we're doing. If you haven't watched the first video, I highly recommend you to do it. But regardless, I hope you have a grasp about what page replacement algorithms are. That's something that we talked about in the previous episode. So let's go ahead and see what least recently used page replacement algorithm is, and we'll try to code the same in Python. Now, let's talk about LRU page replacement. Again, this is the same example that we worked with in the previous video. So I'm going to take this, the frame size will again be 3. That will be the frame size that we're going to be dealing with. And I'll show you what LRU page replacement looks like. Okay, so let's say initially there is nothing, right? So this will be a page fault, of course, but this will be something like that. Then again 0 3 nil 0 3 1. Now you see 2 is there, 2 is not available in my frame, so I have to replace with something. How do you do that? Well, we check least recently used page. What does that mean? Look, 1 was used, correct? 3 used, 0 was the least recently used one. Therefore, let's go ahead and eliminate this 0. Okay, so 2 3 1, that's what it'll look like. Now let's look at 4. Now again 4, you can see 2 was used recently, 1 was also used, but 3 was the least recently used. So I'm going to change this to 2 4 and 1. Okay, now think about this way. Next part is 1 only, so that's all right, right? And then again this 2 is also something that's there. Now when it's come to 3, now in first in first out, what we've actually done is, in this particular case, we've changed it to 2 4 3. We have replaced 1 because 1 came first, but in this case that's not how we're going to be doing. We're going to be checking which is least used. You can see 2 has been used, 1 has been used, but 4 is the least used process. Therefore, let's go ahead and replace 4. 2 3 1. Now when you're talking about 0, 1 is the least recently used process. Therefore, we'll replace 1 over there, and then when 4 comes back, we will go ahead and, so for example, this would be 2 is the least recently used, so this will be 4 3 and 0. Okay, let's go ahead and count the number of page faults. There'll be 1 2 3 4 5. This is same 6 7 and then 8. So the number of page faults will be 8. Okay, which is 1 more than what we had in the FIFO page replacement. Let's go ahead and see how this looks like in Python code. Okay, something that we're going to be doing now is actually we're going to be using the same program itself and writing on top of that. I'll tell you why that is. Okay, so that we can show you the difference between different page replacement algorithms, and it'll make a lot more sense when we have all 3. So I'm just going to go ahead and close this random line for now. Let's go ahead with this, whatever we have here. Let's go ahead and define the LRU page replacement function. So that's the same thing as what we just talked about. So LRU, define that. Obviously this should not be in caps actually, so maybe we can just call it LRU and then set the processes along with the frame size. Okay, now same thing as before, we have a tracker. That's why we're tracking all of this. So let's go ahead and define what this tracker will look like. So tracker will be for I in range of frame size, right? And then you can just say for this in range of len of processes. Okay, that'll give you an empty tracker right now, which is awesome. Let's go ahead and keep track of the page faults also. That will initially be 0. Okay, so what do we need to replace? Replace least recently used. There is no pattern here, therefore we are not using this replace pointer. Okay, so for I in range of len of processes. Okay, let's go ahead and take the process. That will be processes of I. Okay, once you're getting that, let's go ahead and copy previous, and that'll be the same as before. We're just going to be copying in the first case alone. So anything after here, after the 0th case, we're just copying whatever is below, and then from there we're making the changes, right? So if I is greater than or equal to 1, let's go ahead and say tracker of I is nothing but list of tracker of I minus 1. That is why it's greater than equal to 1, because when it's 1, it just takes the 0th value. Okay, now what we need to check if the page fault is there, right? So in case of page fault, how do you check that? If process is not, right, so not in tracker of I, in that case a page fault occurs, correct? So page fault plus equal to 1. So finding out what to replace, right? So initially what we'll do, we'll just fill this out if there's something empty, right? So in that case, let's go ahead and write some if condition. So if there is an empty in my tracker of I, let's just go ahead and find the index of that. So index will be tracker of I dot find, sorry, dot index, I think that's what it's called, of this. So you'll get the index value and just go ahead and set that tracker of I of index, set that to be this process. Okay, once we have replaced all of these empty ones, let's go ahead and write the else part actually. So recent is going to be a variable that we'll be declaring, and that will be nothing but processes of to I. That means let's say 2, this box is where you're taking. I want to take everything from here, the left hand side of this 2, I mean from the start to the left hand side of the 2. From there, what I'm going to check is whatever is available in my frame, I'm going to check the index of that. I want to check which has the least index, that will be the least recently used. Okay, but we have to look from reverse, right? So from here, what and all is the 3 active, from there where we're looking. So what I will do is I will actually reverse the list. Instead of this being 0 3 1, it will be 1 3 0. From there I'll check what the index of 1 is, what the index of 3 is, what the index of 0 is, and which is all of these 3 things inside the frame, and from there I will check which has the highest index in reverse. Okay, and all of this matters. If you check, why do you want to do it in the reverse in the first place? From here itself you can check, right? Well, that's not really right, because let's say you're checking from here, right? There's a 0 here and there's a 0 here also, somewhere in between 3 and 1, say, for example. If I'm not reversing the list, I'll be checking the index of this 0, which is not really the right thing to do, especially when there's another 0 there, correct, which comes after this. So I'm going to be reversing the list and I'll check the indexes from reverse, and from there I'll find out which has the highest index, that will be the least recently used, and I'll go ahead and replace that. If that makes sense, fantastic. Let's go ahead and see how we can do that. So let's reverse the list. Okay, so recent will be list of recent. Okay, and so that just preventing a shallow copy, and recent will be recent of tick tick and then -1. Okay, now then what do? We check which has largest index. Okay, so initially let's just set the into replace to be none. Okay, and then what I'll do is for p in tracker of I. Okay, in that particular tracker I have a set of processes in that frame. I'm going to set the temporary index, that's going to be a variable. That index will be nothing but, in this recent, what is the index of p. Now if the index to replace is none, I will just go ahead and set the index to replace with the temp index, else I'll actually check. So elif the temp index is greater than the index to replace, in that case what I will do is the index to replace, the new index to replace will actually be the temp index, because there is a higher index in the reverse way, right? So once that is done, I know what to replace, what index to replace. At least I will just go ahead and take the element to replace, which will be nothing but recent of in to replace, and this element is nothing but the process. Okay, right, once I'm able to find out what process I actually want to replace, I need to see where this process is in the current tracker. Okay, what that means is, I say I want to replace 3 in this case. Where is 3 located in 231? That I have to find. Okay, in order to do that, nothing. So the index final value will be tracker of I. Okay, dot index of this element to replace. Okay, once you're getting this, let's go ahead and actually perform the replace operation. Tracker of I of this index will now be the new process. If you're able to understand this, maybe we can just, so that's it. Let's just go ahead and print least recently used, and then let's go ahead and print the number of page faults, and then just do page default, and then let's go ahead and do for I in tracker. Let's just go ahead and print I. Okay, so if you're able to understand what we're doing here, I'm just going to copy and paste this over here. Let's just get rid of this over here and then do LRU. I'll save this and click the run button. Okay, you can see that the total number of page faults is 8. Wow, that's right. Let's go ahead and see what goes on. 0 minus minus 0 3 minus 0 3 1 0 3 minus, yeah, all it's the same. Again, we have 2 3 1 2 3 1, and then we have 3 2 4 1s, right? 2 4 1 2 4 1 2 4 1, same thing. Now it's 2 3 1 2 3 0 4 3 0. Okay, therefore we have achieved the least recently used page replacement. I hope you're able to understand what we're doing in this video, what least recently used page replacement is. Obviously, of course, you can also go ahead and run this using the random to show in your lab exams. That's something that we talked about in the previous video. If you don't really understand this line, maybe you can look into that. But I really hope this video you're able to understand what we're doing. If this video helped you, hit that like button. If you have any questions, let me know down in the comments. I'll try my best to answer them. Thank you so much for watching. I'll see you in another video. Until then, bye.